All right, on today's episode of Python Papi, we're back inside our TensorFlow course, and we did start our malaria TensorFlow callbacks module. Let's have a look at what we went over today. Let me get and pull that up. So it was a lot of note taking. We didn't actually write any code. We did write a little bit of code just to build off what we've already been doing, but it's mostly note taking. So let's pick up where we left off. So let's see here. In this section, we'll be going over TensorFlow callbacks. In this section, we will be building callbacks with TensorFlow. In this section, we'll look at how to build a callback from scratch by inheriting from the callbacks class. And then we'll build other callbacks from available by TensorFlow, like the CSV logger, early stopping, learning rate scheduler, model checkpointing, and finally reduce learning rate on a plateau callback. Now, callbacks are methods we call during training, evaluating our prediction. These callbacks can permit us to extract useful information from those processes we just listed, or even carry out changes on those processes. Here in the TensorFlow documentation, we have the tf.corres.callbacks. And the first thing we will look at is the tf.corres callbacks.history, callback that records events into a history object. And we can see that we have been using this whenever we use the history.fit method in our code. We also see that we have been using it in the plt.plot history.history in our code. Next, we will look at the callback class, tf.corres.callbacks.callback, abstract class used to build new callbacks. Now, the reason why this is the most important of all these different callback classes is because this is the modern class or the abstract based class, which can be used in building new callbacks. So if we want to build a callback which isn't listed, we can always come back to this and then build the callback from scratch. So we have this callback class, which has attributes, params, and models. The params, the dictionary training parameters. This is supposed to be EG, not ER. Is a verbosity, batch size, number of epochs. It's supposed to be epochs here. Then we have the models, the instance of corres.models.model, reference of the model being trained. And then it also has its methods on batch begin, on batch end, on epoch begin, and on epoch end, which we'll see how to implement very easily. If we look at the on batch begin and on batch end, we'll see that they take similar arguments. On batch begin, batch logs equals none. On batch end, batch logs equals none. Next, for the on batch begin and the on batch end, they'll actually taking epochs in the logs. On batch, on epoch begin, epoch logs equals none. On epoch end, epochs equals none. With that said, now we can import the callback into our code from corres.callbacks, import callback, C line 10. Then we can define our callback class, which we call lost callback. So let's look at line 10 really quickly to see how we actually implemented that right here. As you can see, line 10, we have from corres.callbacks, import callback. So basically, that's what we did all morning. We just did a lot of note taking. And we actually did write some code here for a class that we labeled lost callback with a callback parameter, define on call on epic end, self epic logs, and all of this stuff. I'll actually go over this tomorrow when we run it. We're not going to run it now, of course. We'll run it overnight. So once I do run it, I'll come back and revisit this code and explain what's going on. But of course, I will keep you posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.